All right, ladies and gentlemen, let's get to it. We're going to be combining some ideas, but at the same time, not really. We're going to be learning a little bit about taking something to a power. And in this case, it's actually going to be a group. Remember back on the first example, we had 4 and then x to the 0, and that 0 only belonged to the x. But how do we know when the exponent belongs to more than just one thing? And the key idea here is when it's a group. So when exponents are on the outside of the group, the exponent belongs to each piece in the group. That means it belongs to the coefficient, and it's going to belong to the variable. Now, later on, we would talk about what happens if there's addition or subtraction. That's a different case. We're not talking about that now, and things do change there. But right now, we're specifically talking about what happens if there's an exponent to a group that has a coefficient and a variable only. The short answer, that variable belongs to all of it. So what we have, it's almost like I don't want to say it, but I'm going to say it because to me it makes sense to hear it. It's kind of like the distributive property. We have to take this 2 and we have to I'm not writing anything. There we go. I have to take this 2 and give it to that y, and I have to give it to that negative 1.5. So really what this problem is saying is my original problem here is the same thing as saying negative 1.5 squared times y squared, and that's the problem I'm actually having to solve. Well, if I do that, negative 1.5 times negative 1.5, I'm cheating. I have it written down already because getting a calculator to pop up, not the easiest thing in the world. So I get negative times negative is a positive, and it's 225. And y squared is just y squared because I don't know what y is, so it's just y squared. It just means whenever I find out y, I got to square it. That's it. And this would actually be my answer. Let me do this and move it down. Ooh, I didn't want to move you. Move you. Ah! Can I? Oh, I can't just do that. Awesome. Still learning a few tips and tricks here. All right. So there's my answer for A. But what about B? Well, again, the exponent's going to belong to the A, and it's going to belong to that negative 10. So really, A over negative 10, all cubed, is going to be A cubed over negative 10 cubed. Now, it's not simplified yet. That A is, but the negative 10 cubed is not. So negative 10 times negative 10 is a positive 100. Then we have negative 10 times 100, which is 1,000, but it's negative, so a negative 1,000 over A cubed. And that would be my acceptable answer there. I say acceptable because there is a different way we could write it. We're not going to get into that detail now. We're just going to keep things as we've known them to be. All right, so let's move on down the line here. We've got this 4, and it actually needs to be going to this D. It needs to go to the 3, and it needs to go to that 2, okay? So what this looks like is 3D over 2, all to the 4th, is the same thing as 3 to the 4th times D to the 4th over 2 to the 4th. So 3 to the 4th is 3 times 3 is 27, times 3 is 81, times D to the 4th, because that isn't changing, over 2 to the 4th, which is 2 times 2, which is 4, times 2 is 8, times 2 is 16. I look to see if I can simplify this. This is 9s, this is 4s. Nope. So here is my answer for C. And on D, again, we're going to be giving this negative 5 to the x, to the 2, and to the 3. Now there's a shortcut, and it's actually covered up here in another way. Remember that if it's a negative exponent, it means it's going to flip. If it's in the numerator, you go to the denominator. If you go to the denominator, you go to the numerator, and it makes it positive. So really, another way to write our problem to actually solve it, to me, a little bit easier and quicker, is to flip the fraction and then make that a positive exponent. Now, when I distribute it, I won't have to flip it afterwards. And for some reason, my brain just makes more sense. This means that I have 3 to the 5th over 2 to the 5th, x to the 5th. Now I'm going to simplify that. 3 to the 5th, again, I have this one written down as 243. And then 2, let's see, 2 to the 4th is 16 times another 2 is 32, x to the 5th. Those aren't going to share any factors, so this would be my answer. Now, to show you what I actually did here, let's distribute the -5 instead and see if we get the same thing. So I'm going to come down a little bit here, and I'm going to go 2 to the -5th times x to the -5th over 3 to the -5th. Now, to get rid of all those negatives, again, this 2's got to move to the bottom to get a positive exponent. The x has to move to the bottom to get a positive exponent. And the 3 has to move to the numerator to get a positive exponent. And all of a sudden, we have the same here. As long as I worked it right, that means we'll get the same answer. So whether we flip before or after we give that 5 to each piece, doesn't matter. Hope that explains what we can do with exponents. When we have something, when we have a group to a power, every piece of that group has to get that power. That's kind of that is the rule, and this is how it's applied.